Okay, I think we're going to start. So in the first part, you basically get an experience of building your API spec, your API, your contract with the client. And the second part, we want to focus some more on tools and how this spec is more driving your development. As you saw, we got up to like lesson 5, which got you all the main functionality basically to work. This is probably the point where we were hoping to get anyway. I'll skip a little bit. Maybe, yeah, here we go. So I wanted to do a quick recap for the lessons we didn't get a chance to go over. So we got into 5 where we saw how you are reusing your definitions. And then in lesson 2, if you go over those slides, we're basically talking a little bit about how you can support with those reuse definition a pagination model, which is a very common pattern that also repeats itself. And then you also see how you can define responses and also reuse responses in your paths. And you can define a default response, and you can define responses for your common error codes like 400, 500, and you don't need to repeat them. You just define them as in the response array, and then similar to how you reuse definitions and parameters, you reuse them in your paths. Then in 7, we wanted to talk a little bit about how to secure your API. So Swagger supports 3 basic secure schemas, the basic of the securing through an API key, and you can see all those examples in the slide, and also full support for OAuth 2. You can see all definitions for how you would define the flow and full support for that. And the last 2 lessons, adding some more documentation. We talk how you define what's called operation IDs for your actions, where that gives ability for automatic tools to kind of parse your action and maybe generate code, things like that. You also can add tags to do logical groupings of your actions or your paths. So you can see those examples. And then in the last lesson, this is where you see that your spec that you're building is becoming very long. It's very hard to maintain. So you can see there how you actually, with Swagger, you have support with splitting your spec into multiple files. You don't have to support everything in just the one file. And there are several strategies how to do that. The strategy that we have examples in the slides is where we basically split it to a file for parameters, definitions, and your main spec is just have your main paths and your main metadata, and this is what you keep there. But there are different strategies to how you would go about splitting it. You can also split it based on paths and things like that. It really depends on the API. So we did that, we did the break, and then we go to part 2 now.
OK, so in part 1, we developed a spec. And now in part 2, we want to show kind of what you get out of doing this. So there are a few benefits, and we're gonna look at examples of all of these in the part 2 lessons. The first one is documentation. So the spec itself is kind of documentation already for your API. But we're also going to show how you can generate other forms of documentation like HTML, PDF, Markdown, and other things like an automatic UI console for documenting the API. We're going to show how you can run a mock server and see, like make requests and get mock responses, so you can see how the API would work if it were implemented, but before you do the implementation. We're going to show how you can use a tool called Dread to do some input and output validation. So it's going to look at the spec, look at the requests and responses that are defined there, and verify that the implementation actually matches that. And we're going to show how you can do some code generation, so how you can take this spec and build out servers and clients and things. So let's talk a little bit about the code generator first. So there are code generators for servers. There are, I don't know, maybe 15 languages supported in the like core code generator tool. And there's a few that are just kind of like a one-time, one-way generation. So you take the spec when it's fully defined, It builds out the server code with stubs for all of your paths, and then you, from then on, you do all the work in the implementation. And then there's some others that are fully integrated, and what this means is the spec becomes part of the application, and so as you make changes to the spec, the application updates along with it, and that's what we're going to look at in some of the lessons. You can also generate clients. So this is really nice because if you are not proficient in some languages, but you expect your clients to be using those languages, you can use the code generator to generate like a Java client or a .NET client for your API, and you don't have to be an expert in those languages. For the most part, they're pretty idiomatic to the language. It's going to depend on the language, though. So I'd recommend, if you do use the client generator, have someone who is familiar with the language test it out and make sure it feels right to them. And then you can use the code generation to generate the documentation. And again, we'll show generating a couple different output formats. So the core tool that's supported by like the actual Swagger and OpenAPI group is called Swagger CodeGen. There are other generators for other languages, but most of them are in this Swagger CodeGen tool. You may have seen links at the top of the online editor or the editor that's in your browser in the VM. So those links to generate the clients and the servers and the documentation call out to generator.swagger.io. It takes the spec, does the work behind the scenes, and then gives you back a packaged up output. There's also a CLI, though, and that is installed on your VM, and there's directions in the VM markdown file in the repo if you want to use the Swagger CodeGen locally. So it's a Java application that will build out the output in different languages. So like I said, there are some servers that are just like one time, but then there's some others that are fully integrated, and so these have like first-class Swagger support. And so there's kind of three big ones. So there's Swagger Inflector, which is a Java framework. There's Swagger Node, which is a Node framework. And there's one called Connection, which is a Python framework. And that's the one we're going to be looking at a little bit later. So now Ian's going to go over a lesson where you're going to generate code in your language of choice.
Okay, so yeah, we'll start from the first lesson where, as Dave mentioned, the reason why we wanted to generate the spec first, because we're doing the spec first building APIs, and then out of that we want the benefit of generating code and not building the spec afterwards. And as Dave mentioned, we'll see an example of generating some of this code using the Swagger editor. So basically, you may have noticed this before when you're learning the tool. Here, you actually have a lot of options based on the spec that you have built during the first half. You can go in and you can choose any of the languages you like. You can try a couple of them. And for example, you can use here generating the Python Flask. And for the API that I have here, the spec, I can download the Flask app for that on the server. I can also do the same thing here and generate either Java or C#, things like that, and also a Python client for that. Now, I already have it downloaded. Let's have a little bit of time getting it defined. And then basically have here both the Flask server that we generated and the Python client out of the spec that I had there. So if we see a little bit on the server, we have controllers. So you would see basically out of the spec that we had, which is similar to the spec that you built in the first half. This is the code we got generated. And you can see here, you have basic endpoints support. You're supporting creating a speaker, but it only generates the stubs for you, and it does here something like do magic and all of that support, and then you would need to build all this logic inside, but you already have all the boilerplate code there. A little bit more with the actual client. That gives you a little bit more of a client that you can maybe distribute to your clients of the API, and then actually goes in and they make requests to your API, and you don't need to worry about all of that. As Dave mentioned, you might want to modify a little bit the code to be more applicable to the language, because some of it is not very readable, but it gives you a great starting point based on the spec that you already spent a lot of time defining to generate the code for you, basically. Now if we go back to the presentation. So we want to give people a little bit exercising with generating code. Now that you spent all the first half defining the spec, generate any type of code that you like, experiment with it, try adding it some more functionality of actually supporting not just do magic, but actually generating some responses. They don't have to make sense. You can do stuff like returning empty list on the get speakers, things like that. And will take 10 minutes. I know some people still have problems with their VM, so let us know. We'll try to take this time to also troubleshoot that a little bit more, because this will be helpful for the next lessons.
OK, so by now you should have generated maybe 1 or 2 clients and servers, and you see like what the code looks like that comes out of the generator. So now I'm going to talk a little bit about the specific implementation that we're going to use for the next couple lessons. And this is the Python one called connection. So it is a Python application, and it's built on top of Flask. It uses the OpenAPI Spec as configuration for the app. So the spec lives inside the app. And as you make changes to the spec, it changes how the app works. And it controls things like routing, validation, the response formats, errors, and all the things like that. It has a couple options for how you configure routing. The first one is explicit routing. So you may have seen in the spec examples the operation ID. If you're using explicit routing, it will map the operation ID to Python package, module, and then a function. And so if you're using this method, this operation ID will look for the hello world function in the API module of my app. You can also separate those, though. So the spec supports extension keys. So here we have X Swagger router controller. And so what that allows you to do is define the controller and the operation ID separate, so that the operation ID can be just a single word referencing it. But for our purposes today, we're not going to do that explicit routing. We're going to use automatic routing. So now this is Python specific. This is something that's in the Python application. So when it starts up, instead of using its default resolver, it's going to use this, this special resolver called REST resolver. And so you'll see this in the implementation code. This is already there for you. But I just wanted to point out a little bit what it's doing. So it's going to take the paths in your Swagger definition and map them to the packages, modules, and functions that live inside this application. So you'll see just /get will look at api.get, and if you look down, like /foo ID will do a get in that foo module of the API. So this handles all that routing for you. So from your spec, you just define functions that match up to what the path name and then methods are. So this framework is going to do request validation for you. It's going to use the JSON schema that you define. And so it's going to use this to validate any parameters that are marked as required. And it's going to validate the input types and formats. You can define custom validators. We're not going to get into that today, but just know you can subclass the validator. And what all of these do is they'll return a 400 error with details about what was wrong with the validation if your input isn't valid. The framework also handles the responses automatically. It uses this, excuse me, the serialization format that is defined in the spec. It uses custom JSON encoder, which is the base Python encoder with some extra things like support for date-time serialization. It can optionally do validation on the output. So this is off by default, but if you turn it on, the server will actually produce an error if your code would have emitted something that didn't match the spec. And again, you can also subclass the validators so that they can be customized. So Ian mentioned that the spec can define your API's security. The connection framework supports OAuth 2 in the spec and a couple different options for OAuth 2. If you want to do API key authentication or basic auth, that's not supported in the framework right now, so you end up having to do it yourself. And there are Flask plugins that allow you to do that if that's what you want to do. And it has a couple other nice features. It embeds Swagger UI, so users of the API can have a developer console that they can use to interact with the API. That's on by default, but you can turn it off. It will emit JSON for the Swagger definition, so that if any of your clients are using an API client library that understands Swagger, it will find it at the root of your API and will know how to use it. And again, because it's a framework built on top of Flask, you can also use many of the Flask plugins, just like it's a Flask application. So it gives you kind of a wide array of tools. And now Ian's going to go over the actual lesson.
So I think by now Dave gave a good introduction for connection. So we're going to look a little bit into the connection application that we put in the VM, where there is actual implementation of a spec similar to what you would have had at the end of lesson 5. And then there is also all the logic to support it, and I'll walk you through that a little bit. So this is an application you would have in your VM as part of the repo that you downloaded. Here under implementation, this is our application. You would see here, if you haven't seen it before, this is a README file for how you would install it and run it. If you have the VM running, you should have everything set up, so you just need to run this last command and also activate your environment, and I'll show it in a minute. And then I wanted to show a little bit about the implementation here. So for the beginning, we have here the speakers controller, which, as Dave mentioned, connection gives you a very easy, basically, connection from your spec that you've written over to your implementation. So all of this is handled by default by connection. And then all you need to do is define the explicit methods. Make it a little bit bigger. The explicit methods where you define your logic. So here, for example, this is how we're getting all the speakers. And connection knows, based on the fact that you have a get for your speakers endpoint, it knows how to route here directly the way that Dave kind of pointed out. And then also it has the post, and then has the put. And then, as Dave mentioned, with the Swagger router specific extension, you can actually define a little bit of different names for your function, but this is the default implementation, basically. And then all you have to do for a new endpoint, you have to go create a new endpoint in your spec, and then go here, create another function that just does your logic without any of the boilerplate that you might need, code that you might need to do when you're creating, for example, a Flask application. You need to also define routes and stuff like that. The other part in the application is it's more specific for it's more specific for our here we go. Specifically for Flask implementation, but you'll need to do some modification later on in the lesson, so I wanted to point it out. The models is actually the object that we're using to serialize our data over to the database. We're using basically SQLite for this application, but here we're using Flask, Python's SQL Alchemy to define the talk object, and then using basically SQL Alchemy DB model and DB column to handle all of the serialization over to the database. So this is the models PY file that if you want to add additional objects, this is basically where you need to add that part. Now, if you have your VM set up, what you would do in order to run the application, you would do already in the Vagrant machine, you would go here and do work on tutorial. Course. And then you activated the virtual environment for tutorial, which has all the setup for the application. Then you run the command I showed it before, python-m, better APIs, and you have your application running. Now, just to see that it actually is running, we'll go back and see something. This is where it gets interesting with me. Need to jump over between a bunch of stuff. So by default, it would run on localhost 8080. And if I go here to speakers, like this, you will see here some data that I have already populated. Now, in this lesson, you would have also in the lesson directory a collection for Postman that you can use in order to post data to your application. And I have it already. You can use any other tools, but we're using for now Postman. And I'll show you here, for example, we're sending some data over to the application. If we want to basically create another speaker, I would send it like this. Sometimes. Saying there is sometimes some conflict with the VM, with my ports. So Postman was a little bit hiccupy for me before. Here, start this again. OK, so here we go. So I posted like another speaker. We got an ID 3 for that. And if we go back to see a list of speakers, we see that this was added to the list of speakers. And this is all handled just by straight up writing the code that you need for your logic. And you don't need a bunch of mappings and stuff for your routes. So now we jump over to another quick exercise. OK, so here you would follow basically the simple, the way that I kind of set it up, where you go into your virtual machine, run the app with the same command. And I recommend look a little bit at the code, explore it, because we're going to change it in some of the other lessons. And then try using either any tool that you like or the Postman collection that you have in the lesson to register a couple of speakers. See that they're in the list, register a couple of talks, and see that all of that stuff match up. OK, I think we're going to continue to the next lesson. I think most of the people were able to run the application, other than hitting a few problems with Postman. I think if some of you saw a problem with the an error from the application saying JSON not supported, something like this. It might be that you have an error in your JSON object, actually, and then missing a comma, something like that, and connection is actually saying that, no, the problem is that you're not sending JSON. So it's a little bit of a weird error that is being returned by default, probably something that should be fixed. So you were able to run the application, populate some data, we saw that, and then the next part we want to see, basically, we have a working spec. We have some contract that we build with our clients. Now, actually, sometimes you want to be able to give this to your client before you're actually doing any part of the implementation. Because something that me and Dave ran into where we were working with some even internal clients, we defined a certain behavior of the API, and then we would implement that. And then when it actually goes into production, and your clients start using that, they're actually saying, no, this is not something this is not how we expected this to behave. So it would be very useful if we wrote the spec, and actually before we did a lot of work of implementing it, not only showing the clients the spec, we actually give them an ability to somehow interact with it. And for that, we kind of being able to run mock server. So thankfully enough, it's quite useful to have connection actually also gives support for a mock server to be able to generate from your spec. And the way it does that, if you add to your responses an array of examples, it's going to, I believe by default, just grab the last example that you put, and they return that basically to your client. So this is a way for basically telling your client, OK, we have a spec, we have a behavior, how we expect our API to work. Now you can interact with our mock server, actually make posts and get, and see what kind of responses you're going to get on endpoints. And then once your clients say, we think this looks good, or we actually want to make some changes, then we can go ahead, make the changes, and start with the implementation. So how would you go about that? Basically, again, your VM, if you're ready, you can open another session in the terminal, or you can use the one that you already had before. You can, as long as your environment, the tutorial is activated, as the way I did before with the work on tutorial, you can run this command. So for example, I'm running a connection run tutorial repo, and right now I'm pointing it to the example in lesson 2.3. And I'm telling it, I want you to mock all of the endpoints right now. So I'm running that. I believe you can change the port, but by default, this is going to run on port 5000. And then if I go here, well, if I can find my mouse. So we go to localhost 5000. Then it's going to send, OK, this actually, this endpoint is not found. This is not defined. Now, if I go to, in the example that we're using, the path store, so it actually says this one did not have a response defined for it. But then if I go to 42, for example, I'm getting back this example that I defined for it. So you can see basically the different behaviors. If you supplied an example for in your endpoint, you're going to have it back from the mock server. If you forgot to add examples to it, but the endpoint is defined, a connection is going to be smart enough to say, OK, this actually doesn't have an example response defined for it. And this is what your clients are going to see, versus a general 404, where it completely can't find it. So in this lesson, so this is the usage basically that you've just seen with a connection run. You pointed it to your spec, and you say it, I want to mock the spec and serve it. And by default, it would be on port 5000, which I believe is also mapped from your VM to your local machine. So in this example, we're going to update your endpoints to as much as more of them to have examples so you can work with them, and then run the mock server, submit requests to it, and see back the responses that you're getting as though you were basically a client of your API. OK, so hopefully all of you got the mock server working and had a few requests pointing to it. Now we're actually going to look at another tool that you can use with your spec. So the same way that you can give your clients a mock server to play around with, see the responses that you're getting, the other interesting part would be basically to do some kind of a testing or validation on your spec once you actually had some implementation. So Dread is basically a testing tool, and I would say even more kind of a validation, not as much testing, that basically reads your spec and then exercises your implementation, your API server, to see if what you have implemented actually matches the spec. So this is a language agnostic tools. It's developed by a company called Apiary, and it supports both Swagger and Blueprint as your specs. And the way it's already installed in your VM, but you can install it locally with using npm for some issues that people are having. So the first part you would need to do is you need to initialize Dread. You would need to basically run the Dread init command. And it would ask you where is the location of your API description, and you would point it to your YAML file. Then it's going to ask you if there is a command to start the backend server, and you can just leave it blank. Then it would be, obviously would need a URL to your server, so you need to tell it it's on port 8080, or you can point it to your mock server, and it would just, the testing would be talking to your mock. That's something to experiment too. Then the other nice part, we won't be experimenting with it, but because Dread is basically just making requests based on the information you're putting in the spec, it doesn't have much of a state information for it. The way they're dealing with it is that you can add hooks using some languages. It supports quite a bit. I think it supports Node.js, Python, I think maybe Java, but you would see a whole list of how you would want to write your hooks. So for now, you can just randomly choose a language. It's not really important since we're not going to use that feature. And then for now, you probably don't want to send the test responses to Apiary. If you do, you need to set up an account, and then it gives you a little bit of a nicer display of your test result. It also tracks it for you, so you can go ahead and play with it afterwards. And then it also has some CI integration that you can use for that. And once you got the Dread init working, you're going to have a Dread YAML file. That file basically is a very basic YAML file that stores all of this configuration. And actually, if you made a mistake or something wrong, you can easily go and just edit that YAML file. Or you can always run the Dread init again and regenerate it. So it's very easy to work with. Now, how this Dread actually works is that in your spec, for the parameters that are being passed, you would need to set up you would need to add another attribute of X example or a default value. Dread is going to find those values and going to automatically send them to your API implementation. Then it's going to get a response back from your API implementation and going to parse the response if it matches what you actually have, if it matches the schema that you have in your spec. And that's what I mean when I say it kind of does only validation. It's not going to actually do any logic to make sure that those values make sense. It's just going to make sure that it matches the schema, the response that you have committed to your clients, how it's going to look. So this is how you would basically update it. If you put the pet ID, you would put here, I chose to use the extension they're using. Basically everything, if you see in a Swagger file, X hyphen, this is like a third-party extension for the spec. So Dread chose to do this extension of X example. And if you put the X example 42, this is the value for the parameter that Dread is going to use, basically, when it is making its request. So I'm going to run real quickly to show you how it actually we're running on our server. So I have right now, basically, as we finished before, a connection, a mock server running for lesson 203 with the example. And we saw that we had example for when we had actual pet ID versus we didn't have really examples for our getting an array of pets. So if I run Dread here, I already run for Dread init, and I have the Dread YAML. So I go here. The interesting part is here where it points over to the example in our lesson 204. And then it actually has this endpoint. It goes to port 5000. So I might actually want to run this with the example 204 because I think this is the one I've dated to have all the examples. Here you go. So if you're following along, so I have the mock server with the example, and then I have dread pointing to that server. Now, if I run dread, and I actually right now just telling it to test only the get actions, because with the post it might become more complex. We might need to use hook to store the actual state. So right now, for simplicity, we're just checking the gets. And then we run dread. And we can see that it did 2 requests. It posted get paths and got a valid response, some kind of an array probably. And then it posted to /paths42, and it also got a response back from our mock server. And we had 2 passing tests. And here the connection, I think, well, I think if I run it with -v. OK. So if I run this again, I just want to show. Yeah. So you can see the mock server. This is the request that it got when you run it with the verbis mode, and it got the /paths/paths42, and those tests passed. So I go back to the presentation. I'll be able to find that one. Yep. So we'll do a quick exercise with the dread where you're going to go to your spec, basically, and update the get actions to past values in the parameters that the dread either put at default or the X example. So the dread would be able to find those. You would also need to do the dread init first to be able to point to your server. And then you would run it exactly as it points here with dread method get, and it would test all of your get methods. So take a couple of minutes for that. OK, I think we're getting pretty close to the end, so we're going to skip the next 2 lessons. Here you would have seen that you had about like 4 tests that passed, and you would have skipped a test because we're only testing the get method. And then I'm going to do a quick recap of we got to experiment with the mock server, do the testing with dread, and some experimentation with the connection app. Then the next couple of lessons, if you want to do them by yourself, is basically lesson 5 is kind of tying it all together, where you would go add a new feature to your spec file, and then run dread, see the dread actually failed trying to make those, hitting those endpoints. Then you would basically update your app and add this new functionality to it, and then rerun dread again and see that those tests kind of passed the way you would do in your development cycle. And then the last part is documentation. Is sometimes you would want to give your clients a little bit of a more nicer documentation and not just the spec file. You would want to give them more formatted HTML, something like that. So if you're running the application that we have right now with connection, if you do go to port 8080-UI, you would actually see an HTML representation with the regular Swagger UI of your entire spec. You also get like a nice console where you can hit the server and something very easy for your clients to use. So those would be the last 2 lessons. Now we'll do a quick recap.
Yeah, actually, so at this point, I just wanted to say thank you for attending, and hope you had a good time. And please, if you can, leave feedback on the O'Reilly site under the session. Use the Rate This Session link. I'd appreciate what you have to say. Thanks.